In this example, the tank contains 50,000 litres of water and the tap is fully on and all the water drains from the tank in 80 minutes. The volume of water remaining in the tank is given by this equation over here. What's interesting about this equation is that it is a quadratic. We might expect that the water draining from the tank drains in a linear way. This would have meant that the water was draining at a constant rate, but not in this case because of the quadratic value, the water is draining at a particular rate which is not linear. And before we draw the rate graph, let's just have a look at the volume of water remaining, the displacement graph. Initially, at t is equal to 0, our volume would be 50,000 litres. And after 80 minutes, when t is equal to 80, then our volume would be 0 litres. Litres here and litres there. Drawing it to scale can be a little bit difficult because the volume of water is going to be very, very large, but the scale for the time in minutes is going to be quite small. And our water drains in a parabolic way, starting way up there and finishing around 80 centimeters. Let's just draw that over there. The reason I've drawn this graph over here, because you can glean quite a lot of information. You can see that the rate right at the top over here, the slope would have been steeper, and as it goes down over here in a parabolic way, the slope starts to decrease. Let's have a look at the rate of change of this water. We'll need to differentiate this function using the chain rule. So dV over dt is going to be 50,000, leaving that there. Multiply that by 2 and put it in front there. So I'll put the 2 down here times 2. We'll leave what's in the brackets and we'll differentiate what's inside the bracket here, which happens to be minus 1 over 80. Simplifying all this down, we'll have minus 1250, 1 minus t over 80 with units of litres per minute. Now that is a linear function, and if we're to draw this graph at t is equal to 0, we will get minus 125 litres. So we can just write over here that will be 1,000 minus 1250 litres. And at t is equal to 80, we'll get 0. So what we need to draw is a straight line. Okay, we've got the straight line here. And from both the parabola and the straight line, we can now say that the flow is the fastest right at t is equal to 0. Here it's minus 125 and it's after 80 minutes it is 0, and so from the volume function we can see that that's the slope here is the steepest and therefore the outflow must be the highest. So outflow was fastest at t is equal to 0. And this happened when the tap was first opened. Now we'll just have a look at the derivative of the flow, the rate of flow of this water, which is here, and we'll show that it is always a constant and positive. And we want to try and interpret those results. Why do we bother looking at the second derivative? I rewrote the derivative function here because I don't like the way it is set out. It's going to be hard to differentiate it. I really prefer it much more in this form, so that then I can say that d squared v over dt is equal to, derivative of that is just 1250 over 80, okay, which is a number. Okay, this number is positive, it's greater than 0. Okay, these three equations, 1, 2, 3, could be compared from kinematics to displacement, velocity, and acceleration. So if you think of this last equation number 3, you're looking at what you're looking at as the outflow increasing at a constant rate, just like acceleration would have been either increasing or decreasing. So because it's positive, we say that the outflow is increasing at a constant rate. What's actually happening to the volume, the change of volume? We can say that the rate of change is also increasing there. One little thing to add, you saw that the rate of change was a negative 1250. Now don't be worried about the fact that it's negative. Just because it's negative doesn't mean it's the smallest number. In this case, it means that the water was flowing out, and so that is still the rate of flow. The rate of flow was the highest at that particular point, but the water was diminishing. Because after all, we're talking about the volume. From here, I'll continue to make videos on the rate of change for a while. So if you want to learn more about it, make sure you subscribe so that you can get the videos.